Okay, class, let me proceed on. So, uh, okay, catalytic reforming, as I told that benzene can be as an undesired product, but it is a carcinogen. Um, so this carcinogen material product from the benzene is produced from the catalytic reforming. Hydrogen sulfide and carbon monoxide gas also produced from this unit, from catalytic reforming unit. And as you know that in catalytic reformer, we are using catalyst. So catalyst, you know, after certain a period, this catalyst is become deactivation due to various reasons. Although we are doing the regeneration, but some spent catalyst we have to take out. So during loading and unloading of catalyst, because it is huge amount, more around maybe tons of catalyst are loading in the reactor. So why loading and unloading, some dust pollutions also occurring, and some particulate some particulate matters when during the loading and unloading activities, some particulate matters also can be escaped, or some catalyst can be escaped to the environment, which is we can say that is that due to dust pollution also. So these things from the catalytic reformer. Next unit, that is thermal cracking and caulking. You know, in the thermal cracking, here no catalysts are using, but normally here cracking activities, meaning that breakdown activities are carried out by using heat. Very high temperature is there, maybe around 1000 degrees centigrade, and in some cases is higher. So coke are produced. Coke, you know, this is a carbonaceous material. So if coke are produced, you know, we have to remove this coke because coke can be in the if coke. So we have to normally coke. We are doing that by combustion, by applying hot air. So combustions. So in that case, again, carbon dioxide, or due to impartial combustion, carbon monoxide can be escaped. Another thing, since in thermal cracking unit, that high temperatures are using, so the unit must have uses the huge amount of cooling water, because the equipment must be cooled down, circulating water. So in refinery, actually the cooling water is very important, because not only in the thermal unit, in some other units also, due to cool down, the water is circulating. But when the water is circulating, it also there is heat exchanger occurring, so produce the hot water. So this hot water goes to cooling tower, reduce the cooling temperature. So whenever these activities is going on, this cooling water can be also, uh, uh, produce waste, some waste material, such as it has been found that around 3.5 to 5 cubic meter of wastewater produced per ton of uh, crude oil refining activities from cooling water, from cooling tower. See, per ton, if you do the refinery activities per ton of crude oil, it can produce around approximately 5 cubic meter of wastewater due to cooling tower, because cooling water, as you know, that huge amount of cooling water we are using. So this cooling, it is because cooling tower, this is like a fan, by applying fan. So hot water from the top, it goes to, from there are some trays are there. So hot water from the top goes down, and uh, water temperature become reduced and reduced. You may see this cooling tower even in our FKJ also. Wherever you see the central, AC, air cooling system. So for cool down the water temperature, they are using cooling tower. In every big shopping mall also, or big building also, you might see that very big fan continuously moving, and water from top to bottom it goes, and due to fan, that water temperature becomes reduced. This is actually cooling, cooling tower. In refinery, cooling tower is very big cooling because we have to use huge amount of water. So cooling water can be soluble because hydrocarbon. There are a lot of hydrocarbon are very easily soluble in the water. So can contain soluble water, or this water may contain sulfide also, some metals also, ammonia, etc. So mainly from thermal coking unit, the harmful substance, that is the one first thing, that is coke, and another is water pollution due to from thermal coking, cracking. Then next activity, uh, that is hydrocracking and hydrotreating. You already know hydrocracking or hydrotreating. This is at presence of hydrogen, right? Hydrocracking meaning that crackdown occurs by the help of hydrogen. Hydrotreating meaning that some impurities removed by applying using hydrogen. Hydrogen itself a toxic, and very it can be release energy. So we have to be very careful when you deal with hydrogen because it is very explosive. So hydrogen, it can be produce huge amount of energy. So you have to be very careful. Moreover, in hydrocracking unit, since we are using catalyst also, so if this catalyst also we are doing the regeneration, so we have to be very, while we do the regeneration, some coke, due to that carbon dioxide or carbon monoxide can be escaped. Next activity, that is fluidized catalytic cracking, FCC. In FCC unit, we know that mainly that the hydrocarbon and catalyst not in fixed bed position. It is a fluidized bed. I think you might still recall. So this and another thing in fluidized catalytic cracking unit, the another unit, that is the regeneration unit. Catalyst become continuously regenerated, because in the fluidized catalyst, whatever the surface of the catalyst, it can be blocked. It can be blocked with coke. So this coke has to be removed. So how we are doing removing? You might recall that we applied hot air, meaning that combustion. So hydrocarbon react with oxygen. So combustion occurred and definitely produce carbon dioxide. Carbon dioxide is a greenhouse gas effect. Another thing, if in the regenerator the partial combustions are occurring, so it can be produced carbon monoxide. So these are the harmful. So these things. And another thing, some spent catalyst, whenever we do the loading and unloading, again the same problem. Dust, pollutions are occurring. Plus the particulate matter can be escaped to the environment. It is happening. Next activity, you might recall recently, last week we have gone through, that is the alkylation process. Alkylation process, we are using acid as a catalyst, right? As a liquid phase. Normally sulfuric acid, and also using hydrochloric acid. You know that sulfuric acid, this is a corrosive. So we have to be very careful when you deal with acid. So, these are the problems occurs and also on water contaminates also with this acid also can be lead as a explosion. So these are the problems. See, and also one thing we have learned from desalting, starting from desalter, crude oil, then reforming, thermal cracking, fluidized catalytic, everywhere the issues related with environment. As I told in beginning, that not only one problem in refinery. not only air pollution or not only water pollution or not only solid. Solid also, heavy, huge amount of solid produced. As I told, around 3 to 5 kg per ton, 3 to 5 kg per ton of crude, produce solid materials, sludge. So, see, water also polluted, air also polluted. Air polluted can be not only hydrogen sulfide, SOx or NOx. In addition with this, because in hydrocarbon there are a lot of volatile organic compounds are there. Normally it is calling VOC, volatile organic compounds. So these volatile organic compounds, meaning that it is very easily very low boiling point temperature. Very easily it becomes gas or vapor phase. So it can be escaped to the environment. Lot of volatile organic compounds. So again, so this is the pollution. Uh, so what I intend to tell that see in every unit there are issues related to the environment. So we have to the last, although we didn't cover that, just for your information that on the bottom, the vacuum from the vacuum distillation unit, although we produce the vacuum gas well, which can be converted to gasoline, but the lastly, whatever not can be converted in the gasoline, that is calling the asphalt or bitumen or pitch in other word, which can be used as a the road itself for the construction of road, the pitch or asphalt. So in the asphalt also there is another unit before throwing as a uses as a asphalt. There is another unit calling de-asphalting unit. So because de-asphalted oil also can be converted into gasoline. So de-asphalted unit also they are using some additives like phenols, amines. So phenol itself is a very harmful substance. Even though phenol, if touch with your skin, so this phenol can be penetrate throughout your skin to your body, which is very harmful. Very harmful substances phenol. So you have to be very careful. Phenol, amines, and other solvents, whatever uses in the de-asphalting unit. So these additives also can be your problem with your health related issues, because phenol itself, although you don't have any cut or any injury in your skin, but if phenol can be penetrate like a normal skin, it can be penetrate through the outer layer to inside your body. Phenol, very harmful substance. So these are the problem with this. Another thing, the lastly, that is hydrogen production. What we didn't cover it because I didn't add this in your syllabus until alkylation. We have gone through, but just for your information, that hydrogen can be also produced because we are using hydrogen in the hydrotreating unit or hydrocracking. So actually, this hydrogen can be produced from methane gas. From methane gas, we can be produced hydrogen. Hydrogen, this is itself a very very potentially hazardous gas, and it can be in hydrogen production. It can be also carbon monoxide or carbon dioxide can be also escaped. So see, as I told that in every unit in refinery issues with environmental. So we have to work with it. These are the things what I already informed little bit, but these are there is one slides. So you can see that we see here the type of waste and quantity. As I told, the wastewater from cooling tower system, whatever is uses normally in the thermal cracking unit. So around 3.5 to 5 cubic meter wastewater produced per ton of crude. Polluted water, it can be 100 to 300 milligram water per liter. Desalted water, oil or grease can be contained. 1 liter desalted water, there you will found around 300 milligram oil. Benzene also, it is a carcinogen, but it may contain in the wastewater, that is around 1 to 100 milligram per liter. Solid waste, huge amount of solid waste, 3 to 5 kg per ton. VOC, as I told, VOC, that is the volatile organic compounds. Volatile organic compounds also huge amount emissions from 0.5 to 6 kg per ton, higher than solid waste. Volatile organic compounds can be escaped. Other emissions such as benzene, toluene, xylene, although it is low quantity, but it can be also produced as an undesired product and can be caused as an environmental issue. So you may go through these slides, maybe recall, can be memorized because these are some figures that maybe questions come like what are the wastes from the refinery. So you have to able to get the answer. So as I told, maybe can be some elaborate type questions also come, like what are the gas waste or what are the water waste. So these are the quantities, but you have to know what are the gas waste. Gas waste, I already told several times. Hydrogen sulfide, carbon dioxide, carbon monoxide, SOx, NOx, all this. Water can be contaminated due to chloride, ammonia, metal, such as lead, or can be, arsenic, etc. Solid waste, this is sludge or, the spent catalyst. This is also a huge amount of solid waste, spent catalyst, I mean, which is not no more usable. Other things also, not only from the units, from the petroleum refinery units, emissions are escaping. In addition, normally we know earlier days to increase the gasoline number, we use the lead. Lead, this is a metal, heavy metal. So, but if we use lead, lead, in petrol, for example, you can increase the octane number. And as you know, if you increase the octane number, product is valuable. But problem is this is a heavy metal. Heavy metal, that is a serious issues for health concern. So that is why the lead has been banned, no more usable. But it is true that if you use lead, octane number you can increase. But nowadays it is prohibited. Then instead of lead, I already told you, you already know that another additives are used that is calling MTBE, methyl tertiary butyl ether. MTBE, you have to able to know that additives actually, if you use in the gasoline, octane number is increasing. But nowadays in MTBE, that is actually not soluble in the water. So this is one of the and actually the our soil also, it cannot be absorbed. So this MTB can be escaped to the water, so it can be polluted. So nowadays, although still now are uses these additives MTB as a to increase the octane number, but nowadays the uses of MTB become lower and lower because the environmental issue. So that is why nowadays to increase the octane number, alkylation process are carried on instead of uses additives. But in the alkylation unit also, problem with because we are doing with acid. Acid is corrosive, and some spent acid also it's difficult to handle. But however, it is less harmful than to use lead or MTBE. Okay, so see, so these are the emissions. So see here, wastewater, solid, gas. So everywhere polluted with from a refinery. So these are the quantities. So please go through that. Okay, now we'll see. So we have learned what are the waste and what are the waste produced, what are the quantities also, and each unit, what are the emissions released to the environment. Now we have to go through how we can do the what are the waste management. So how we can deal with this waste. So waste management, there are three categories in waste management. One is estimation of emissions. This is very important. Estimate. The process engineer, you have to know how to estimate the emissions. There are some formula. We will go through that. Emissions, the gas emissions or water pollution emission, how to calculate, we will go through that. After estimation of emissions, then we'll know there is some treatment process of controlling. One of the treatment you already know, that is the flare system. Simply burning. All the toxic gas burn. But also problem is there, although it is a very common practice, that is burned, that is the by flare system, flare, F-L-A-R-E. So flare simply burn out the toxic gas, that's all. But as you know, for combustion of hydrocarbon, produce carbon dioxide, carbon monoxide. So that is why global warming, that is the problem that we cannot avoid still. But there are some still high technology, like for example, as I told that due to NOx, that ozone also can be higher. So there is a ozone, there is some burners, special type of burner to burn the nitric oxide emissions. Incinerator is there. Incinerator, meaning that with high temperature, just burn also. It is like a incinerator normally for the solid waste. Incinerator are used for normally for solid waste. A flare normally used for gas waste. When solid waste also burn, there also produce huge amount of ash produced. So there is some. So we will. There is a one slides. I will go through that. That what are the waste treatment and waste minimization and prevention also. How to we have to know that how to waste minimization. One of the technique waste minimization, that is to keep the catalyst activity, meaning that regeneration we have to do very properly. All the process variables should be maintained very properly, because if catalyst become deactivated or not regenerated properly, first things, yield will be lower. Another thing, the emission will be escaped. Emissions that like SOx or NOx, carbon dioxide or carbon monoxide will be escaped. So catalyst activity has to be maintained very well. This is one thing we can do the minimization. Then flanges, all the connection has to be checked periodically. So like that, we can do at least some minimization. Okay, so now we'll go one by one how to do the estimation. Please, as I told in beginning, take your own exercise book, pen, and calculator. We'll do some calculations there. Gas waste. Gas waste, you already know what are the gas waste, right? We told hydrogen sulfide, then carbon monoxide, carbon dioxide, SOx, that is sulfur dioxide, or nitric oxide, or nitrogen dioxide, etc. So gas waste, what they are doing? We are simply burn it out by flaring system. Collected, all the gas collected in the manifold, that is called blow down system. This is actually the calling the gas treatment process. After the treatment, because there is a sulfur recovery unit also there in the gases, because as I told earlier, although sulfur is very harmful substance if contained in the crude oil, or if we proceed without removing sulfur, hydrogen sulfide will escape huge amount. So that is why we are doing hydrotreating process. Hydrotreating process, then we capture the sulfur, goes to the gas processing unit, and after that, also whatever the produced the hydrogen sulfide plus sulfur dioxide, we can produce sulfuric acid. That is valuable product. So meaning that whatever the harmful gases, hydrogen sulfide, yes, it is harmful, but we have to capture it. Then we do the gas processing plant. After that, this hydrogen sulfide can be converted into valuable product, but should not allow this sulfur with the presence of sulfur crude oil treatment. This is not allowable. This is not recommendable, because this hydrogen sulfide and other complexity which you already know that may be happen due to these impurities. Okay, so these are the gas waste. So see here there are some recommendations and some regulations that these are the sources that, as I told, the catalytic cracker or catalytic cracking unit. So here is just for your information that emissions from catalytic cracking can be organic. HAP stands for hazardous air pollutants. HAP, hazardous air pollutants. So organic hazardous air pollutants or can be inorganic hazardous air pollutants. So as per regulations, organic hazardous pollutants allowed should be below than 20 ppmv. ppm, you know, parts per million. V meaning by volume. Maximum allowable amounts of organic hazardous air pollutants, that is, should be lower than 20 parts per million by volume. If inorganic, then around 500 parts per million by volume. Hydrochloric acid, if liquid, then maximum allowable is 30 ppmv. These are the as per US regulations. Actually, it may vary in some countries, but it is actually the ranges. Almost these are the things. So organic, see, the pollutants can be also divided by organic and inorganic. Organic should not be higher than 20 ppmv. Inorganic still until 500 ppmv is allowable. Now we do one again class, maybe within 10 minutes, maybe can be interruption. So we'll come again. So first, emission estimation. We'll do that. Please read this example. Now we will do some calculations. See here. Please go through that. Fuel containing, please everyone make sure that you have calculator with you. I will ask you questions. I will tell you how to do that. Actually, in your ebook also you can find this. But now we will go to, because in ebook there are some errors also, and some you know, as you know, they didn't show, the authors didn't show the full procedure. Some are escaping, so we have to go through this. Calculations are not very hard, but we'll go through one by one now. First example: fuel containing 4 weight% sulfur is burned with in a furnace to heat crude oil. Before introducing to the crude oil distillation unit, we have to calculate the amount of sulfur dioxide from the furnace stack per 100 kg of fuel burn. Also, we have to calculate what is the amount of air. Two things. We have to find out the sulfur dioxide, amount of sulfur dioxide, and amount of air for combustion. So first things, here, what are the informations given? weight percentage of sulfur, 4 weight percent, and also given the total, how much the kg mass of fuel to be burned. That are the information given. So by using these two information, first things, first thing we can calculate the amount of sulfur in fuel. Can you please do that? Amount of sulfur in fuel. Please do that. Information is given 408% of sulfur and total fuel is given 100%. I give you tips. One thing, for example, amount of sulfur you can calculate. See, 4 over 100 times this 100. Simple. Because this is what percent is given sulfur, right? So first things, first step, amount of sulfur in fuel equal to 4 over 100 times 100. 100 this. So amount of sulfur in fuel is 4 kg, right? Now, molecular weight of sulfur dioxide, that is, you know, that sulfur, that is 32, oxygen 16. So 16 times 2 plus 32. So equal to 64. And molecular weight of air, that is 29. Since it is given in kg, so basis will be 29 kg per kilomole, and the molecular weight of sulfur dioxide will be 64 kg per kilomole. So now write the equation, that is sulfur, how sulfur dioxide is producing, that is sulfur plus oxygen equal to sulfur dioxide. 1 mole sulfur react with 1 mole of oxygen, produce 1 mole of sulfur dioxide. Since we have calculated the amount of sulfur in fuel, so now if we want to calculate the amount of sulfur dioxide, simply we can calculate that 4 kg, what are the total sulfur amount, divided by molecular weight of sulfur, that is 32, times molecular weight of sulfur dioxide. Please let me know what is your answer. Please, anyone can tell me? Simple calculations. Please tell me the answer. Amount of sulfur dioxide.
8 kilogram.
Very good, 8 kilogram. You understood how you got that 8 kilogram, right? Because the sulfur we produce, the amount of sulfur in well, we got 4 kg. So 4 divided by molecular weight of sulfur times molecular weight of sulfur dioxide. So we got 8 kg of sulfur dioxide. Now refer the equation. 1 mole sulfur react with 1 mole oxygen, produce 1 mole sulfur dioxide. So mole of sulfur, can we calculate number of mole? Number of mole, can we calculate? Manjula?
Yes, doctor.
Can we calculate number of mole of sulfur?
Yes, doctor.
How?
Mass divided by molar mass.
Very good. Mass over by molar mass. So what are the answer you got?
I got 0.125.
Okay, so that is 0.125. The unit?
Yes.
Unit?
Mole, right? Kilomole.
So very careful. Basis here is kilo, right? SI unit, not mole,
Yes.
kilomole, everywhere. Basis
Yeah.
here is kg, right? In SI unit we are using, right? So
Yeah.
it should be kilomole.
Mm.
If here, for example, gram, we have to, that one we can write mole.
Okay.
Okay. So now see molar number of mole of sulfur we calculate. Number of oxygen, number of mole of oxygen. Can we calculate? Daini, 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 Elisandra, Elisandra.
Yes, doctor.
Okay. See, uh, number just now we calculate the
Yeah.
number of mole of sulfur. Can
Yes.
we know the number of mole of oxygen?
Can. Can,
How?
doctor.
How? How?
Since 1 mole of
Very
sulfur
good. Very good. I
react.
understood. Same. Very good. Very good. Because the 1 mole of sulfur react with 1 mole of oxygen. So mole number will be the same, right?
Yes.
Thank you. Thank you very much. Okay.
Okay, doctor.
So since we calculate the number of mole of sulfur, meaning that that is the number of mole of oxygen also, that is, as Manjula told, that is 0.0125 kilomole. So now say we have, because our intention to find out the air required. So in air, oxygen percentage is 21%. Nitrogen is 79%, we know. So now, number of mole of oxygen we calculate. So directly from using that, number of mole of oxygen divided by molecular weight of air, no, divided by oxygen percentage in air, that is 0.21, sorry, 0.21, yes, 21%. So that number of mole of oxygen divided by 0.21, you will get the number of the amount of air or air mole. So please tell me what is your answer you got? Number of mole of air. Please carry on, please. Fahim, 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 Shikin, not Shikin, Shikin. Okay, so the amount of air, we can calculate the amount of air, that is the mole